Okay. So another method that we can use for descriptive SQIR is MAIHDA. Specifically MAIHDA, where our strata are defined by contextual variables. So MAIHDA refers to multi-level analysis of individual heterogeneity and discriminatory accuracy, and it's a very popular and flexible method for quantitative intersectionality research, and it also has a lot of helpful features that facilitate this type of work. However, going into the nitty-gritty of MIDA and all of its possible extensions is really outside the scope of this session. So we're just highlighting the specific adaptations of MIDA that are particularly relevant to SQIR specifically. And so in this adaptation, individuals are nested within intersectional strata, and these strata are defined by contextual factors. They can also be defined jointly by individual level social identities. And so, for example, we could imagine having strata where the strata are jointly defined by structural sexism and structural racism scores, but then also individual level gender, sexual, and racialized identities. I'll get a little more concrete with this in a second. Um, but first, when we want to use this method is when we're interested in obtaining stratum specific, so for a given group, prevalence estimates for many different groups or strata. And when we want to be able to partition the outcome variance into the components of individual level and strata level. And so there are two key benefits of this method. First, it's really good at handling small sample sizes because of its automatic precision weighting of all estimates and its shrinkage towards the overall sample mean. And this is rooted in multi-level modeling broadly, so that's a common benefit of multi-level modeling. And also, it allows for estimating stratum-specific prevalence estimates, and these have really straightforward interpretations. So, for example, we could obtain the prevalence outcome for an intersectional group where that group is, for example, white cisgender women living in states with high levels of structural racism and high levels of structural sexism. And then we could obtain another group that is another intersection. Like for every single group, we can obtain those estimates, and it's a key benefit. And then there are two key challenges of this method. So the first is again, compared to single level analyses, it is methodologically complex and computationally demanding. And second, it typically requires large sample sizes. And so in this study conducted by Claire Evans, who developed MIDA, but this is a later study of Claire's, individuals were nested within intersectional strata that were jointly defined by gender, race, ethnicity, and parent education, as well as neighborhood and school poverty status. And so this figure here is showing the stratum-specific prevalence of cigarette use, which is the outcome for each intersectional stratum. So an example interpretation could be the prevalence of cigarette smoking was around 15% for Black males whose parents have a college degree or more and who attend a non-poor school but live in a poor neighborhood. That is a really valuable estimate to have, and you can generate it for every single group of interest. And also, from this figure, we can see that this method also allows us to easily identify intersectional strata that are at particularly high or low risk of the outcome, but also importantly to identify any patterns that might exist across similar contexts. So for example, we can assess whether, importantly, for us who are thinking like, context and structure, whether attending a poor school, living in a poor neighborhood, both or neither are associated with greater inequities across social groups that are defined by gender, race, ethnicity, and parent education. So in more simple terms, we can identify how much those contexts matter for shaping the inequities that we observe across social groups, and that is inherently very valuable for SQIR. Okay, the final method, like you've made it through almost all of it for descriptive SQIR that we'll be covering is cross-classified MIDA with random slopes. So it's again in the MIDA sphere. And this method is a multi-level modeling approach that includes contextual exposures. So we can be thinking about, state level structural gendered racism as an example by including random intercepts for both intersectional strata, where those strata are defined based on intersecting individual level social identities, but then also random intercepts for our other context of interest. So for instance, states. And then we include random slopes for our contextual factor of interest, which is state level structural gendered racism. In that example, we have one contextual factor of interest. If we have two separate structural level measures, what we would do is include random slopes for each of them and then include an interaction term between those random slopes. That is methodologically more complex and more difficult to interpret, but it is possible. And so when would we want to use this method? In a couple of circumstances, when we're interested in examining how the magnitude of association between our contextual exposures and the outcome vary across those intersectional strata defined by intersecting social identities. And importantly, when we feel comfortable treating intersectional strata as conceptually the same across contexts. So what that means is that we would feel comfortable generating an overall outcome prevalence estimate for example, white cisgender women aggregated over all states, as opposed to generating state-specific estimates for every single state. But what we're saying when we do that is that the experience of being a white cisgender woman is similar in Massachusetts as it is in Ohio. And so that's just something that we are conceptually doing. And so we'll want to be thinking about that in terms of our interpretation if we go that route for analysis, or if we use this method for analysis. However, a key benefit of this method is that it allows for the association between the contextual exposures and the outcome to vary across intersectional strata. It does have two key challenges, but these are related similar to the other MAIHDA approach that we discussed, where it's methodologically complex and computationally demanding, but that is in comparison to single level analyses, where again, we're not adequately accounting for the fact that our data are nested. And second, it typically requires large sample sizes. Okay, so in this study led by Ariel, our goal is to estimate how the association between campus climate and eating disorders varies across intersectional social strata jointly defined by gender, sexual, and racialized identity. So to do so, we are using this multi-level modeling approach where we included random intercepts for the intersectional strata that were jointly defined by those social identity variables, and then also random intercepts for college campuses because the students were nested in college campuses. And then we included random slopes for campus climate across and allowed it to vary across intersectional strata. So this figure is showing the stratum-specific prevalence of probable eating disorders across the range of campus climate values, where the values closer to 1, so closer to the left of any given column, correspond to more hostile climates, and then values closer to 5 correspond to friendlier climates. So what we're visually seeing here is that for a 1-unit increase towards a friendlier campus climate, that was associated with an 8% lower odds of probable eating disorders, which is quite massive, to be honest. And so importantly, the magnitude of this association varied across strata, with multiply marginalized students experiencing the biggest benefits from attending a very friendly campus. And that is a really important observation to make if we care about equity. Okay. Okay, so now we've introduced this framework for descriptive SQIR, and we've covered some example research questions and also worked through some methods examples that we can use to conduct this work. But in reality, there's actually very limited, as I mentioned, truly descriptive work published in the literature. What actually often happens in practice is that researchers will set out with a descriptive aim, like some descriptive question that they want to answer, but then they decide to adjust for covariates. Like at least age, but also sometimes just a slew of covariates. And so what this leads to is that our research question actually then fundamentally changes from one about the world as it exists to one about the world as it might exist in some hypothetical reality that actually does not exist. And so one research question that's written to sort of allude to this, hypothetical way of asking questions that we are getting at is, after accounting for a set of covariates, let's imagine that's age, region, and income inequality. So let's imagine that those differences were not existent. What is the joint patterning of multiple systems of oppression? And again, we can extend this research question to think about time, place, and populations in relation to health outcomes, et cetera. And then an example research question that's a little more specific would be, in a hypothetical world in which such age, region, and income inequality differences did not exist, what is the magnitude of racialized inequities in maternal mortality in states with high levels of structural gendered racism versus in states with low levels? And so what you might be thinking about is that these hypothetical contrasts are describing the world as it doesn't exist. And that then raises important questions about who our findings are actually applicable to, if anyone, in reality. And then also, what are the interpretations and implications based on these analyses? Like, what can we actually do if these populations don't exist? And so, again, if we're trying to adjust for variables as a way of isolating the impact of our exposure of interest, like if we really care about what is the effect of structural gendered racism, and we want to adjust for all these variables because we're trying to isolate that impact, then our thinking is truly causal, and we should be using more of a causal framework. And so we'll get into that in a second. And so what we're advocating for is that a lot of work actually ends up falling in the middle, and they end up not doing a descriptive analysis or a causal analysis, and it becomes really unclear what the analysis actually results in terms of actionable evidence.